Good evening, everyone. My name is Rachit Neema, IT-2K24-71. Today, I am going to present solution for internal test 2 for the subject Numerical Analysis and Design, taught by our professor Shaligram Prajapat sir. So let's start with the first question. The first question is the population of the city in a census taken once in the 10 years is given below. Estimate the population in the year 1925, 1975, and 1984. We have the data with the gap of 10 years with the population in thousand. For example, we have in 1921 we have 35,000 population. In 1961 we have 120,000 population. So we need to find different 1925, 1975, and 1984. So first we will make the forward difference table. For the forward difference table, we write down all the years and with respect to all the population size. And we apply the formula for forward references f of y. For the del y, we write uh, x1 minus x upon h, which is give result to 7, and so on. We find the forward reference table for del y, del square y, del cube y, del to the power 4y, del to the power 5y, to del to the power 6. Now we apply to compute u. We have 9 for 1925 forward reference. We will use u equals to 1925 minus 1921. 1921 is the base A we took from the forward reference table, and 10 is the difference between the um years. So by computing this, we obtain the value of u is equals to 0.4. Now we apply in the formula y equals to y0 plus u del y0 plus u minus 1 upon 2 factorial del square y0, so on. By computing the forward reference table, with the help of the forward reference table, we obtain the answer for the estimated population in 1925 is 36.75, which is approximately 36,750 people. Uh, the thing to be noted is this answer is in the range between 1921 to 1931. Now for the second and third part, we use backward interpolation, backward referencing and extrapolation. So for the 1975, we use Newton's backward method for the same, which we take base as 1975. For the 1975, we take the base as 1981. Computing the formula, we obtain the value of u is equals to 1975 minus 1981 divide by h, which is 10, which results to the value of minus 0.6. By using the difference table, we opt putting the formula, we will obtain the value 185.56, which is equal to 1,85,518 lakhs, 1,85,560 peoples. And using the extrapolation, we take the base 1984, 1981 as a base, 1984, compute the value of u, which is 0.3, and putting in the equation, which result as 239.44. The thing to be noted is that the population estimated in 1975 is in the range between 1971 to 1981, and the extrapolation is out of the range, which is 1981. So we need to we note this. For the second question, we have two-dimensional table given below using the interpolation to find f of 2.5 and f of 3.5. We have this given table. With the help of this table, we need to obtain the value of 2.5 and 3.5 dimensions. So for the two-dimension interpolation, our target is f of 2.5 and comma 3.5 centered between grid points by linear average of four neighbors. So we put this into the formula, which is f equals to 1 upon 4 f of 2 comma 3 plus f of 3 comma 3 f of 2 comma 4 f of 3 comma 4. To be noted, these all values are the four neighbors of around 2.5 and 3.5. By computing this, we will get the final value of 47.5, which is our answer for the equation. So the value of f of 2.5 comma 3.5 is approximately 47.5. For the third question, we have the given data, and in this given data, we need to use Simpson rule to evaluate the following data. We have given x minus 6, we have given in size of this, and f of x for the respective x. We are using Simpson 3 by 8 rule. Using Simpson 3 by 8 rule, we can evaluate the data. So first we need to find the step size. So finding the step size is 0.1, difference between 1 x or x0 or x1 minus x0, and we must evaluate the n, which is the multiple, which is a 3 multiple, by putting in the Simpson 3 by 8 rule formula. Simpson 3 by root 8 formula states that 3h by 8, here h is the step size, y0 plus yn, which is the first value of y and the last value of y, plus 3 of f of 3 into all the values from y1 to the yn minus 1, excluding the 3 multiples, plus 2 into 3 multiples, like whichever value is multiple of 3, like y3, y6, y9, so on. So by this we evaluate the formula 3h by 8, y0 plus yn, lower plus higher, plus 3 times y1 plus y2 plus y4 plus y6, excluding the 3's multiple, plus 2 into 3's multiple, which is y3 and y6. By this we evaluate the value is 2.8875, which result in the value for the using Simpson's 3 by 8 rule, Simpson's rule. The fourth question states that integrate f of x 2x cube minus 3x square plus 4x minus 5 from the range minus 2 to 2, where a is given minus 2, b is given 4, and we have to take n equals to 4. And with regarding, we have given Gauss-Legendre form, using the Gauss-Legendre formula we need to find weights, and for the given we have all given for the number of point, which is 3 for the respective value, 4 for the respective weights, and 5 for the respective weights. To evaluate this integration, we will use Gaussian-Legendre formula. What Gaussian-Legendre formula states, we need to find f of x, then evaluate f of 4 and evaluate f of minus 2. So first we need to convert these range from minus 2 to 4 into minus 1 to 1. By doing this, we have for the integration we have 2x cube minus 3x square plus 4x minus 5 from this range. We will change the antiderivative. We will make it antiderivative. We perform the derivation. We put the value f equals to x equals to 4 and evaluate the value 76. Then we put x equals to minus 2 and evaluate the value 34, and the exact integral, which will be f of 4 minus f of minus 2, which will be result in 76 minus 34 equals to 40. Now the next question we have is write a program or draw a complete flowchart for Newton forward difference interpolation formula. Uh, in the first question, we use interpolation for Newton's forward difference interpolation formula. According, we have Python implementation of this following forward difference formula. In this program, what we are performing is we taking n as an input from the user, the data points. We are initializing x a matrix and y a matrix from the range 0 to I, for the j in range of n, the given input by the user. We will enter the value x and y for the evaluation. Then we consider a for loop from I to the range n by converting the floating point and append to the xi position. Now we construct a forward reference table in this. To construct a forward reference table, we use the loop for j equals to in range 1 to n. We exclude 0 because we always start from the first position, second minus first, and we use another loop inside a loop for I in range n minus j to compute it with the limit of j. Yij is equals to I plus 1 and j minus 1 minus Yij minus 1. By this we will ended up getting the all the values from the reference table, forward reference table, and we print it on the screen. By using that, the user has given us the data points and the points to be evaluated. We put in the interpolation value and calculate u from with respect to h. So h is equals to x1 minus x0, which gives our step size h, and u is equals to the value given by the user minus the base value, which is x0, divided by h. Ended up getting u. Uh, After getting the all the required value h, u, and the value, we will put the all values in the Newton forward formula, where the sum is equals to y00. We take p equals to 1 and fact equals to 1, and we run a loop for to get all the values from the reference table from range 1 to n, where p equals to p into u minus 1, u minus I for the u minus 1 and u minus 2, and so on. We will use I as an iterative value and to evaluate this, and fact equals to fact into I. And after that we will return the sum will be equals to our value. This is how we calculate. Now we will see the flowchart for the same. Here we have the flowchart for the Newton-Raphson method. We will start. This is the algorithm flowchart where we start. Take the input from the user. Input x1 and y. Construct a forward reference table. Using the table, we take an input formula for the Newton interpolation. And by the help of that value x, we compute h in y, h in u, step size and u, and then we initialize sum equals to y0 and compute interpolation terms using Newton forward. All terms compute. If all the terms are computed, then we will print the interpolation value. If not, we will run this loop multiple times, and once we get the interpolation value, we'll print on the screen and stop the algorithm. So this